So,
Yeah. Okay. Thanks, Rajagopalan.
okay, sir.
Yeah. Okay. Arjun, how are you? How's your leg?
Uh, yes, sir, it's better now. Actually, I'm not able to put weight on it. So after Sunday, I was struggling a bit.
Oh, yeah. Take care.
Yeah, yes, sir.
So I'll introduce you to Vanilla later. So you can.
Okay.
No problem. Uh, I think we'll start. What I'm going to do is introduce to you some formulas on series. Okay, and just explain. I'm not going to derive it. Just to say these are very important for clinicians. So I'll also explain through the problems. We'll also see why these things are important. Okay, uh, slightly difficult, but nothing to worry. This because it is the formulas are the ones where series. These are see the series are they are very important. So we will come back to solve the problems a bit later. So there are sequences, okay, and so these sequences form what are called as series. Uh, we have seen this in in recursive techniques, and as we work it out, you would notice that they become very important uh, in many situations. So those situations where you can use it, we will do that using our problem. Okay. Now, so what is a series? Like for example, yes, not. So you remember we started with T naught, with T naught. From T naught we went to T1. From T1 we went to T2 in time. In time. So we can write say ST is equal to some ST plus 1 plus some value here and so on. Sorry, what am I doing? Sorry. ST plus 1. So ST plus 1 is equal to ST plus some quantity. That we will see what those quantities. Okay. So then if I now start expanding ST, okay, I can keep expanding. Say, for example, I can have S0 is equal to A. S1 is equal to A plus R. S2 is equal to A plus R squared. We will see the example in a minute. S3 is equal to A plus AR squared plus AR cubed and so on. So Sn will become like this. Okay. Now, the point is, what is Sn? Can I get a formula for Sn? Is that clear? Can I get a formula? Should I keep on adding one after the other? Okay. So, can I get a formula for Sn? So, that is the question. So, the formula for Sn is given by this. This is the equation. Okay. That's the first thing. A plus AR squared plus AR power n, so on, is equal to A into 1 minus A into 1 minus R power n plus 1 divided by 1 minus. Okay. So is that clear? Okay. This is expressed in terms of yeah. Let's see how we are going to use this tool, right? So that's our. So is that clear? If this is the case, that is the equation. Okay. Now let us look at this drug concentration. I think I have given this. That's how to use it. The drug is administered. This problem is with you, right? With the solution I have put it. That is it with you?
Yes, sir.
Yes, sir.
Yeah. So drug is administered to a patient at the same time every day. Suppose the concentration of the drug is Cn after the injection on the nth day. Okay. Before the injection, the next day, only 30% of the drug is present in the preceding day, remains in the bloodstream. Okay. So if the daily dose raises the concentration by 0.2 mg per ml, find the concentration after 4 days. You can find the concentration after n days. That's not a problem. Okay. Now, let us write down an equation for this. So n is days. Right. So for example, n can be the first day. So C1. So you can see that C1 is equal to 0.3 C0 plus 0.2. Why? Because 30% of the drug present in the preceding day still remains. So what you have given on the 0th day, when you started the treatment, okay, that is multiplied by 0.3. So this is what is remaining in the bloodstream. Plus, on the first day, you are given 0.2. So that is 0.2. Then C2. What was in the 0.3, that is 30% remaining at the end of the first day, plus 0.2, and so on. Is this clear? So C3, 0.3 at the end of the second day, plus 0.2. So you can write down this equation in a more general form like that. Cn plus 1 is equal to 0.3 into Cn plus 0.2. Any questions? Arjun, clear?
Yes, sir.
Okay. So I can easily find out. So what is the fourth day? What do you mean? So first day, second day, third day, fourth day. I can keep first day I can find out this, second day I can find out this, third day is this. So fourth day is 0.283. Over. Okay. So now this is an interesting thing. What is the interesting question? The interesting question is, if you keep giving this drug every day, okay, as a doctor, do you think that it will keep on increasing? Every day you give an injection. Okay, let's say 10 days you give. Will it keep on increasing? What is your answer? Or will it reach a saturation? Looks from what you have seen for 4 days, it keeps increasing. Joseph, what do you think?
I think the C is large enough, it will reach some value. Tends towards like an asymptote.
Let us try it out.
Yeah.
Okay. Now, so will it asymptotically reach this value? That's the question. Correct. Will it reach some value of, say, C as the n number of days increases? Right?
Yes,
so
sir.
let's look at this equation. So Cn plus 1 is equal to 0.3 Cn plus 0.2. Right? That's the equation. So asymptotically reaches value of C means what? Which means that after some time, as n increases, Cn plus 1 is equal to Cn is equal to C. That's what it means. So n plus 1 is here, n is here, n plus 1 is here. Okay. And then it will be n plus 2 is here. And so all of them will be one value. Here, one value, which is called C. Okay. So how do I find this out? N tending to infinity. That's what it means. N becomes large. So look at that. So n tending Cn plus 1, n tending to infinity, 0.3 Cn plus 0.2. So limit as n tends to infinity for 0.2 will remain 0.2. So it is here. So Cn and C, both of them is C. So limit as n tends to infinity, Cn becomes C. And limit as Cn plus 1 tends to infinity, that is also C. So the equation becomes C plus 0.3. C is equal to 0.3 C plus 0.2. Okay, so rearranging, bringing it to the side, 0.7, this is what happens, and C is equal to 2 by 7. So, interestingly, that is the limiting concentration. So, limiting concentration is this. What does it mean? Maybe it can be at the 5th day, okay? If it reaches to 0.2857, then it will remain constant in your bloodstream. Is that clear? Guys?
Yes, sir.
Yes, sir. Yes.
So it is interesting. But usually you would have thought that I keep on giving everyday injection. So 30% remains. So you keep on going up. So there won't be any tapering off. This is, you have not done this before. This is what you will be thinking. So there will be an overdose. The concentration of the bloodstream will keep on increasing. But look at the maths. Shows that it won't increase. Yeah, it won't increase. So how do I now apply the equation which we learned? What is the equation we learned? Yes, yeah. So isn't this the equation which we are looking at? You think so? Because so this is the type of equation we are looking at, right? So RCN. Okay, so in other words, remember this equation. I'll come back to this equation 5. This equation I'll apply. So Cn is equal to, this is of the form Cn plus 1 is equal to Rc plus C. Okay, so this is what is the type of equation which we had, where C is equal to 0.2, R is equal to 0.3, C is the previous one, C naught is equal to 0. So go back to this. Okay, so if I now write, for example, if I want to write down S2, okay, then I can write down S2 be S1 plus S2 is equal to S naught plus AR. S3 is equal to S, sorry, S2, sorry, yeah. So our form, the form of our equation is Cn plus 1 is equal to RCn plus C. This is the equation we had. R is equal to 0.3. So does it fit into this equation? Let us see this. Let us write S1. S1 is equal to A is S naught. Okay. S naught plus what? R into S naught.
Yes,
Right?
not.
Right? Okay. S2. What is S2? S2 is equal to A plus R. First, what is that first term? What is the first two terms?
S1.
S1.
Yeah, S1. plus,
S naught
okay,
into R square.
yeah. So R into, so no, don't write like that. I have to now rewrite it in a fashion. So how should I write actually? I shall write S2 is equal to S1 plus R into A. A is of my CL. That's, sorry. A. Am I- R into S1, okay, plus A. That's how I should write. Okay, to get this form. Clear? S3, I should write it as R into S2 plus A. Clear? That's how I should write. Is this clear?
Yes, sir.
No? Cn plus 1 is, n plus 1 is something like Sn plus 1. Sn plus 1, instead of C, I'm writing is equal to R into, instead of Cn, I'm writing Sn plus, instead of C, I'm writing A. Clear? So that it's in the same language. The same language. Let us see, this is the way it is satisfied. So let us say S1. S1 is equal to A, that A is here, A, plus AR. S naught is A, so it is R into S naught. Satisfies this equation. Let us look at S2. S2 is equal to A, this A is there, okay, plus R into S1. Am I right? This is how you should write. So what is that? A plus R into, what is S1? A plus R S naught, right? So what is S naught? A. So I'll just replace S naught by A. So what is this equation? A plus AR plus AR square, right? So that is what is S2. So S2 is written like that. So Sn plus 1 is written as R into Sn plus. If I can write Sn plus 1 is equal to R into Sn plus A, if I'm able to write like that, then my equation is given by this value. Is that clear? Sn is given by this value. Any questions? So actually, this equation is Sn is equal to Sn plus 1 into R plus A. That's the equation. As I say, Sn plus 1 is equal to Sn into R plus A. So that's the equation. So when I keep substituting for, or in other words, let me put so that I don't confuse you. Sn is equal to Sn minus 1 into R plus A. Okay. Now, when I keep substituting for Sn minus 1, then it becomes Sn is equal to, for Sn minus 1, how do I write? R into Sn minus 2 into R, okay, plus A, then plus A. Then I keep substituting for Sn minus 2. I keep on substituting. Then Sn minus 3, Sn. So I will get the complete Sn to be of that form. And if that is the form, the sum up, the summing is given by this equation. Is that clear? So, in other words, if I have a form like this, then Sn can be written by this formula. Let's come back to this. Okay. So Cn plus 1 is equal to Rcn plus C. So what is C? Now compare that with the previous equation. What is C actually?
A.
A. A. Right?
Yes.
What is S actually?
C.
C. So this equation is Sn plus 1 is equal to Rsn plus A. That is the equation. If this is the equation, okay, then the Cn value is, look at that. a into 1 minus r power n plus 1 divided by 1 minus r. So that is 0.2 into 1 minus 0.3 r power n divided by 1 minus r. Because r is, what is this r? 0.3. C 0.2. C naught initially 0. So this is the equation you get as the sum is 2 by 7. It just simplified 2 by 7 into 1 minus 0.3 whole power 1. Clear?
Yes, sir.
So what is important in this equation? Why is it not exploding? Because when limit as n tends to 0, 0.3 power n, we go to 0. Why? Because look at this, 0.3 into 0.3, what is this?
0.09.
Now multiplied by another 0.3.
0.027.
0.2027.
27.
2
Sure.
7, is it correct?
Yeah.
Decimals, 2 decimals. 0 3 points, sorry, correct. 0 point, right? 0.027. So then another 0.27 multiplied by 0.3 keeps on decreasing. Clear? So when n tends to infinity, 0.3 power n will go to 0. Right? Okay. So that is equal to 0. When will it not go to 0? It will explode. When will it explode? This limit.
Negative.
Negative will go also minus, plus, minus. So it will be oscillating and still going down.
Greater than 1.
Greater than 1. So that is the condition. Right? Greater than 1. You keep on multiplying. Say, suppose it is 2, just for example, 2. N is equal to 2, 2 into 2, 3 into 2, into 2. So I go up to infinity. This fellow will explode. So you are not exploding because the concentration which is now absorbed and limits is only 0.3, which is less than 1. So that is the reason why when limit as n tends to infinity, you are getting this number. Clear?
Yes, sir.
So
So
what
this
if
is a
that
series
what if
solution.
that R value was just 1, sir? Instead of 0.3,
No,
it was
no.
just 1.
Yeah, 1. Tell me what will happen. N tends to infinity 1.
It'll just be 0.
0.
Okay, limit.
Be careful. One power n. What is it?
Is 1 only.
1.
1. Clear?
Yeah. And Cn will be
So,
0.
so 1 power n. So 1 minus 1. So Cn will become 0.
0.
Oh, you are telling Cn to be 0, is it? Okay,
Yes.
okay.
Yes, sir.
Yeah, I'm talking about limit this number. Right? So, but if it goes above 1, then you will keep on multiplying. Clear?
Yes.
Yes, sir.
So there are other infinite series. These are infinite series. As n keeps tending to infinity means infinite series. So let us, if the sum is between, so this can be actually simplified if it is AR, A plus R plus AR plus AR squared plus thing. When R is between -1 to +1, it is A by 1 minus. This is A by 1 minus R. If it is between, R is between -1 to +1. Now, we can just check that. So here, say for example, in this case, A is equal to 1 and R is equal to half. How would this series would look like? It will be 1 plus half plus 1/4 plus 1/8 and so on. So Sn will be something like this. And so, in fact, you can find out that to be. So let us now look at when R is equal to less than 1. Let us look at limit as n tends to infinity. A minus A divided by 1 minus R. That is the formula. Okay. Now, let's check whether that formula holds good in this case. Okay. Does it hold good in this case? Will this formula hold good in this case?
R is less than 1, so it should.
It should. Let us just substitute this and see. What is A?
A 0.2.
0.2. What is the formula? 1 minus?
By R. 0.3.
So what is this?
2/7. Yes.
Right?
Yes.
So if this is the formula you have, many times you use this formula for your cases. For absorption, for example, is A by 1 minus R, period. Very simple. So if you are going to give drugs like this, everyday injection or every 2 days, you can sum this up. And what is the saturation limit? Given by this formula. Let's stop here for a minute. Is that clear? Any questions? So as long as obviously the absorption rate should be less than 1. As long as the absorption rate is less than 1, it won't expand. I can easily find out what is the saturation limit by just saying A divided by 1 minus R. Right? Okay.
Yes.
So these are some of the formula which I wanted you to remember. So the next question, did you attempt these questions? Yeah.
No.
No?
No.
Yeah, you have attempted, man. You two guys know how to do this. Right. So a doctor prescribes 100 mg of antibiotic tablet for every 8 hours. Just before taking the tablet is taken, 20% of the, now tell me how to do this. Now you know. Tell me what is the answer.
So 0.2 into 100 plus every
Yeah.
3 hours.
So note that this formula is for infinite series, infinite. But
Yes.
if I now want to use it for n, I can't use this formula. Understood? This is for n, infinity. Okay? If it is n is not infinity, a number like fourth day, then I have to use this step. I would use this first step. Okay? This is for infinity, infinite geometric series. If it is for n days, I will use this. Now let's see how you're going to solve this. Can you try? A. How much of the drug in the body just after the second tablet is there, after the third tablet? So we are asking
After
about
second tablet, 120.
so
120, yeah.
C2. Okay, C2 is what? So how much is that into that is
C1.
0.2 into 100 plus
C1.
100.
plus
100.
Okay. So AR, this is A.
Yes.
So this is 120. C3, easy to calculate from this itself. 0.2
2 into C2 plus 100.
A plus AR squared actually.
Okay.
So I can say C.2 into C2 plus 100.
Plus 100, yeah.
So what?
124.
124, right?
Yes.
124, right? And so on, right?
Yes.
Now, if you have given this, you are going to give this for 1 month, right? You are going to give this for 1 month. How will you calculate?
C30, 0.2 into C29 plus
What is the
100.
formula?
Point
There's the
0.
formula.
It's
20. So 0.2
Into C1. A into 100 into
See, this is
100
the
into
formula.
1 minus
1 minus 100 raised to
100 into.
Sorry,
It
not
should be 100
Up.
into.
100 into, that's the formula. 100 into
1 minus
1 minus
0.2
0.2
raised
raised
to
to 30.
30
30.
divided by
1 minus
1
0.8.
minus 0.2. 1 minus 0.2, right?
1 minus 0.2.
Oh.
Now, obviously this is going to be a big number. Okay. But
Approximately
usually
250.
saturation would have reached. Right? So
Yeah.
what is the saturation if I want to calculate what is the saturation? Because 30 is a big number.
Yes.
A by 1 minus R. What is A by 1 minus R?
100 by 0.8. So
250.
Okay. So
yes.
that is the saturation curve. 250 mg. 250, 0.8. No. No.
125.
1000 by
125. 125.
125.
1000 by 8. 125. Look at that. Third day is 124.
Just
Let's
one.
look at fourth
Yeah.
day.
Yeah.
0.2 into 124. 24.8.
124.8.
Almost the fourth day you are reaching. Isn't it interesting? Did you think about it like this?
No,
Doing
sir.
an injection, huh? Fourth day, the concentration in the blood will be the same. It won't increase. Right? Okay.
Yes, sir.
So now, so what? Find the formula for Q, and that is what we had just now seen. So the long run that we had seen 125. So we have all these problems we have seen. Can you do the 14th problem? Okay, I'm going to do one thing. Right. Now that you understood this series, problems should become simple. So I'm going to give you 5 minutes to attempt, or 2 minutes, whatever time you take, to attempt 14th question yourself and give me an answer. Two of you, so it's easy. So a patient is injected with a drug every 12 hours. Immediately before each injection, the concentration of the drug has been reduced by 90%. The new dose increases the concentration by 1.5. What is the concentration of 3 dose after 3? Right? So that's the question. So what is A?
1.5.
A is what?
R is 0.1.
That's all. You need to do this problem. You know how to substitute.
Yes.
Right? Okay. Any questions, Joseph?
No, sir. Clear.
Clear. Okay.
Yeah.
So actually, the limiting concentration becomes 1.667. That would be the concentration. That's all. Now, this problem, I would like you to attempt this. That's the difficult one. Very interesting problem. As you go towards 6, 7, 8, 9, problem becomes more and more difficult. Not difficult, but more and more involved. Would you like to attempt? No, guys?
Yes, sir.
Okay. Would you like to attempt the problem? So patient is infected with a virus that triples its number every hour. The immune system eventually kicks in and reduces the replication rate by a factor of half, in addition to killing 500,000 virus particles per hour. But this does not happen until the virus reaches a load of 2 million particles. Now, first question you ask, why? So the first question as doctor, what do you ask? Hey, it's a viral fever, it will go down. Will it go down? That's the first question.
Yes, sir.
Combat the infection, the infected receives hourly doses of an antiviral drug. Further reduces the replication rate to a value of 1.25. And the immune system, the drug together can kill 25 million copies of virus per hour. Okay, now the following other questions. Right. So So what is the recursion for the number of viral particles in the absence of treatment and before the immune response starts? What is the equation for the number of viruses? That's the first question. Can you attempt?
Would it be 3 raised to x?
So how do you write a recursive equation? So n t plus 1 is equal to something into
Three.
t.
3
Okay.
times and
T. Yeah. So generally RT. So 3 times. Okay. NT. So NT plus 1 is equal to 3 times NT. Now, let us start from N1. So how is this equation? N1 is equal to R into N. Clear? At 0th day. What is N2? How do you write N2?
R into
R
N1.
into. So what is the equation?
R square and into N naught.
Two.
N naught.
So R, what is RT plus 1?
It's it's N naught into 1 minus R raised to
2.
1 minus R raised to N by 1 minus R.
N0 into R power R raised N0 into R raised to
N naught into 1 minus R.
1 minus. Look at this carefully. What is N3? Let's put more terms.
R raised to N plus 1.
Correct. So R3 is what? I mean, sorry, N3 is what?
R cube into N.
R4, R raised to 4, no, R cube.
Wait, how R raised to 4?
Plus N,
R into
N2.
N2. What is R into N2?
N2 is R square. Yeah, okay, R cube.
Into N0. So,
Correct.
so NT, let's say NT is what? N0 into
R raised to T.
Clear?
Yes.
Okay. So even if there's one virus, look at the replication. R is what? 3. So this becomes N0 into 3 power T. Look at how it's exploding. 3 power T. What, you can calculate. So that's the explosion. So the reproduction rate or the growth rate, 3 explode. Now, what is the question? How long does it take for the immune system to be activated after the infection starts? There is an equation for this length of time for an arbitrary initial number n or something. Okay. So what is it saying? The immune system, when does it kick in?
When it reaches 2 million.
2 million. 2 million.
Yeah.
Okay. Now, assume that first this is what is that the immune system kicks in at T1. something. Right?
Yes.
You guys, you are with me, Arjun?
Yes, sir. Yes, sir.
So I'm going to now write n t1. How do you write this?
N0 3
n0 to
3 raised to
3 raised to T1.
okay, right? 3
R raised to T.
R raised to T1.
T1. Now I want to find out T1. Right? That's the question.
Yes, sir.
Take log n.
Right? How when it's kicking. In these equations, the best thing to do is write down n t1 by n naught is equal to r power t1. Right? Write it like that. Clear?
Yes, sir.
And then take a log. All the time when it's like this, take a log. So reverse log of n t1 by n is equal to t1 into log base log to the base area. That's a natural log. We always take it with natural logarithm, plus told otherwise, into
R.
so t1 is equal to log of n t1 by n naught divided by log of
R.
that is what. Well, what is divided by means
Minus.
minus. So t1 is equal to. So nt1 is what? Sorry, n that is nt1. This number is what? 2 into 10 to the power of 6. So the numerator is ln of 2 into 10 to the power of 6, right? Minus ln of n naught. N naught some value, I don't know. It can be the initial thing.
Yeah.
Divided by r is what? 3. So what does that mean? What is this? So when I do this calculation, simple calculation, this divided by this is 13.2. I know it because I've already worked out 13.2 minus 1 by
Initial.
ln 3 is 3.91. So that's the equation. What's an interesting equation? What does it tell? What does it say? But still, I'm in class. I just got the teaching. So what does this tell? Joseph, what do you understand from this equation?
If ln N0 tends to 1, then the answer would be 13 point. The
What is n naught?
initial concentration.
Yeah. So what is it? What does it say? What happens when
N naught is 1.
1 means there's only one virus. As n naught increases, what happens?
That number tends to 0.
No.
The whole term, 0.9 into
Yeah, but generally, as a doctor, I'm asking you to conclude.
and not increasing. The initial load is viral load is very high.
Exactly. What is the conclusion? Come on. Good. Initial load is high. What happens?
Very severe infection.
No. Initial load is high. What happens to T1?
It's smaller.
Smaller. So what does it mean?
The
Different.
immune system kicks off
Kicks.
sooner.
Sooner. So a guy is infected a lot more. The infection, the immune system kicks in earlier,
Faster.
right?
Correct.
Yes, sir.
This is something. Do you recognize? I don't know. You have to tell.
No.
No. No.
because this is obvious. This is realistic because immune system kicks in only if it reaches a threshold number.
Yeah. Yes, sir. Yeah.
Right. So if the fellow is infected with one, immune system will kick in only after 13.2 days.
Yes. Sir.
If it is a lot more, immune system kicks in
Kicks in
faster.
faster. Yeah. So more severity means it acts faster. Yeah.
Yeah, immune system acts faster. But is that
Can we
mandatory?
also
No.
say if R is also
Yeah.
how does T1 change with R, sir? It's a similar reasoning. If uh, if R is larger, then log of R will be smaller, so T will increase. I mean, T will be sooner.
Sooner. Right.
So like faster.
Sooner.
Yeah. So faster multiplication means the initial viral load will be. I guess both are same
Effect.
situation, right? Yeah. Same effect.
Yeah.
Oh.
Right. Okay.
Yeah. Yes, sir.
I don't know whether it is good or bad because look at that. It is cause-effect relationship. If he gets a fever, you will start immediately some antiviral if it is.
So should we wait on the antiviral then? Because if you're going to reduce the replication rate by giving an antiviral, it's indirectly going to slow down when your immune system kicks
Let
in.
us see that. Let us see that. That's the next question. So, what is the recursion for the number of viral particles after the immune response has begun? So, in other words, okay, what is the recursion formula once immune system has kicked in? How will you write the recursion? Right. So now, what is when immune system kicks in? What happens to R? It has come down 1.25 replication rate, not 1.25 to
1.5.
1.5
Yes.
half 1.5. Okay. So how will you write the equation? So let's say R in mu. How will you write the equation?
So NT is equal to N0 into 1.5 raised to T.
Uh, so
We have to consider the initial
let us
value.
say that, let's
Yeah.
now say that T2 is the time since the response is initiated. So there is one T1, 0 events. T1,
T2.
okay. Now, in this period, it is R. In this period, it is R immune.
So T minus T1. Okay. Yeah.
So this is called first phase, let's say. This is the second phase.
Yes.
So how will you modify it?
So the new time should take account of the T1 also. Like T2 minus T1. Like
So this is T2 is after okay. After it has
yeah. So any T in that phase would be T minus T1.
in so how do I write? So let us say that in this step, let us say that immune system is going to kill some viruses.
Yeah, 500%. Yeah.
Okay, fine. So let me call that as T immune. Okay. So what happens now? N T plus 2 after T1 sorry plus 2 T2 plus. So let's say T2 plus 1 in this phase. Okay, I'm going to T2 and so on. That is all things after in the phase 2 is called the T2. So T2 plus 1. How will you write this? R immune, right? R immune
Times NT2.
NT2, then
Minus 500.
minus T immune, right? So
Yes.
not only is this has reduced to 1.5, there is also a minus. Right? So there is also a minus. Clear?
So this minus is every hourly, right? So how do we account for like each hour 500,000 is reducing? So
Yeah. So the time becomes hourly.
okay.
The time becomes hourly. Clear? So we will start from here, T1. Okay. So we will start at first NT1 into NT1 kicks in. So NT1, let's say plus 1. That is T1 is ended. Let's say it's ended. T1 is the end of the first phase. So how will you write this now?
1.5
R immune, right? Into NT. NT is, we know the formula. That is R immune. What is the formula? 13.2
minus 0.9.
no, not that is time. R immune into N at T1. What is that?
R times.
2 into 10 to the power of 6. That's where
Oh.
immune system has kicked in. That is NT1,
Yes, yes.
right?
Hmm.
Minus
D immune 500,000.
T immune,
Yeah.
500,000. Right? This is the formula. Then N T1 plus 2 is equal to same thing. Now R immune multiplied by N T1 plus 1 minus 500,000. Right? This is how it goes.
Okay. Yeah.
Okay. So let me convert this into, let me call in the second phase as T2. Calling second phase as T2 phase. So that N, what the difference between T1 is the last, this number is called T1. Up to that,
Yeah.
it's say T. So from T1 is one number at which it has kicked in. So so the T2 phase is NT2 plus 1 is equal to R immune multiplied by NT2. T2 is in this phase minus T immune. That's the formula. Clear? Is that clear?
Yes.
Yes.
Logical. Nothing great.
Yeah.
Okay. Now do the fourth one. What is the condition for the viral population size to decrease over time solely because of immune system? Is this even possible? So one of the things that you guys say is that antivirals are not there, so it will go on its own. Body will fight.
So R is less than 1. R immune is less than 1.
So let's see. But you're not going to decide. This thing decides, right? So when, as a mathematical formula, how will you put it? The viral population has to decrease. What does it mean in mathematical terms? Mathematical terms. After immune system has been born, what does it mean by mathematical? What is meant by the term that viral population has to decrease?
The slope is decreasing.
No, we are talking about the recursive formula.
So R into.
So what is the
N2
difference between two steps? Delta n. What is the difference between two steps?
less than 0.
Less than negative.
Yes, that's it. Hey, fantastic, guys. T2 plus 1 minus NT2 to be
Less than 0.
Less than 0.
right.
Yeah.
So write down that equation. Write down that equation. Substituting here from here to here. Write down. So what is delta? What is this? First step. So R immune
NT2
NT2 minus
minus D immune
minus
minus R immune into.
less than 0, right?
Yes.
Rearrange the term. NT2 into R immune
Minus 1
minus 1
minus D
minus
immune
should be,
less than 0.
wow, that's the equation. Right?
Yes.
So let us rearrange this term. How will you rearrange this term? Take this to the next.
NT2 into R minus 1 less than D immune.
Yeah. Now, what is that I'm interested in? I'm interested in NT2. Okay. When will this happen? Will this happen? Right? After which NT2 plus 1 is greater. Okay? When this will happen. So how do I write this equation?
NT2 less than D immune by R immune minus 1.
Less than D immune, fantastic.
By
R
R
immune
immune
minus 1.
minus 1.
Now tell me what this is.
R immune should be greater than 1.
NT2 less than D immune 50,000. Sorry, 500,000.
500,000.
500,000, right?
Yeah, 500,000.
500,000
By 1.5.
This is 1.5 minus 1. This is
1.5.
0.5. What is this?
1 million.
What will happen?
Less than 1 million.
Less than 1 million. If the count is less than 1 million. So, doctor, what is your conclusion?
Yeah.
So without drug, if it reaches 1 million, means it will.
No. Look at that carefully. When is your immune response kicking in?
2 million.
Yeah.
Oh, so it is not possible.
It's not possible unless that immune system kicks in earlier. Okay. With less than 1 million, then only antivirals have no effect.
Yes, sir. Yes.
Yes.
Else, the immune system has to reduce that 1.5, which should keep on reducing. More active. Or else, it's not going to work. Clear or confusing?
Clear.
Yes, sir.
Okay.
Yes.
Now, the fifth question. What is the recursion for the number of viral particles in the presence of both the immune system and the drug? Now, you are given the drug. Fortunately, there's a drug. Now, what is that? Very simple. So, that's the third phase.
Yes.
So, N T3 plus 1. Because I'm adding another fellow here. That's the third phase. Well, how will you write this? R drug into NT3 minus T drug, right?
Yes.
What is R drug?
1.25.
1.25. Right?
Yes.
Okay.
Mm.
Is that clear?
Yes, sir.
Yes.
Now, 6 is similar to what we did before. Just read the 6. What is the condition for to decrease over time when the drug and the immune system are both acting? Is this possible? Can you do this? Very interesting results. Can you do this? Same. So how do you do this?
So, like NT3 less than D drug by R drug minus
What is
C.
delta? Sorry, what is delta N now? The same.
23 should be less than 25 per 10
25
power.
million.
250,000.
No. NT3 will have to give no same equation here. Less than
Yeah.
D drug
25 by R drug minus 1.
D drug is
25 million.
divided by 1.25
1.
minus 1.
0.25. So 1 billion.
Billion.
Yeah, 1 billion.
100 million.
100 million. Yeah.
So unless you give the drug before 100 million, okay, this is not going to work. Right? So you can
Yes.
calculate the time. Unless our immune keeps increasing, the fellow is going to really go into serious trouble.
Yes.
Calculate this, the day, time, T3. You calculate. Right. 7 to 7. So if the how much time do you have to start that drug? If it is 1. I'm going to do one thing. I want 7 and 8 are slightly more involved and difficult. Okay, 7, 8, 9. I'm not going to do it. Can you attempt this? But Arjun, Joseph, can you attempt 7, 8, 9?
Yes,
Now
sir.
that you're
Yes, sir.
not difficult, but working. So you have to work it out. What do? You use that formula which I said, a into 1 minus r power n divided by 1 minus r. That formula you have to use. Okay. Solve for t. Yeah, t2. That's what you have to do. So what I suggest is you work out 7, 8, 9. If you are not able to work out, I give you the result. Is that okay? Would you like to try?
Yes, sir.
Yes, sir.
So interesting, isn't it? How virus, drug, the interaction. Now you understand the immune system. Mathematically, you can understand this. I don't know whether you guys are taught like this.
Definitely not, sir.
No, sir.
It is quite realistic, right?
Yeah,
Very
Yes.
realistic.
and logical also.
Yeah, logical. So you know how to actually understand this whole result.
Yeah.
Yeah. So I'm going to leave this at this point of time, 7, 8, and 9, for you to work out. Then what is the further problems? Yeah, next problem is simple. I think now you know the formula, you can work it out. The MATLAB, I just wanted you to verify. Okay. And the rest of it are just simple. Just try the rest.
Yes.
So I've given some notes for that. So this, if you have noticed, the series has a major role to play. That's why I introduced this. Exponential, series, all these things have a major role to play.
Yes, sir.
So there is that using MATLAB, verify the following equation I have given. Why is this problem? Because when you can't substitute n directly, infinity by infinity, no meaning. But interestingly, when I'm not going to ask you to derive it, but you put it in MATLAB, you get 2. Just want to warn you that you can't substitute infinity and then get some problems. Okay.
Yes.
Right. So I'm going to stop here.
Yeah.
Work out the 3 problems. If not, I will work it out and give you the.
Yes, sir.
Okay.
So I think a few, maybe 1 or 2 theory classes still, if you want, you can have. So, for example, some eigenvalues into linear algebra, we can expand some of the things. But I'm not going to do that now because I want to revise from the beginning all the things. Now you understand how to. So I want to do differentiation, integration, and all that, and then we will.
Yes, sir.
But I think I may have to stop this week because Shanti, I want her to be available. As soon as she's available, we'll start it.
Yes, sir.
On
Okay, sir.
weekdays, we will check. Weekdays, if they are available, we will start it.
Okay, sir.
Offline.
Yeah.
Okay. Now, so I'm going to introduce one course next semester. So summer, I hope we can do something on data science.
Yes, sir.
And next semester, I'm going to introduce this course on direct mechanics and respiratory mechanics.
Yes, sir.
How actually the greater extent mathematical models are used to may not be useful to you, but for Joseph it will definitely be useful.
Yes, sir. Yes, sir. Yeah.
For you, Arjun, it may not be useful directly in your research, but it is. I mean, let's see if there's no other course you can take this also. I would like you to take it.
Yes,
It
sir.
would, it
Yes,
would
sir,
be
yes, sir.
interesting to learn how we as engineers look at your cardiac system. But this course will be run by me as well as the other doctors.
Oh. Okay. Yeah.
Who run this course. Okay,
Yes, sir.
so we'll stop
Okay,
here and work it out. We'll meet again sometime, whenever there's a free next week. So,
Okay, sir.
Okay.
okay,
Thank you.
Okay,
Thank
sir.
you, sir.
Thank you, sir. Thank you, sir.
is it difficult or is it okay to
No,
start?
sir, I'm able to understand that. It's
Yes, sir.
actually
Both
very
you guys
exciting.
are both you guys are with me.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Thanks, Arjun. Get well soon. See
Yes,
you.
sir. Thank you, sir. Thank you.
Okay. Bye. Bye, Joseph.
Thank you.
Bye.
Bye.
Good
Thanks.
night, Srinivasan. Good night. Bye.
Good night, sir.